Okay, so view. Okay, so last time we were discussing how to sketch graphs of equations in polar coordinates, and I wanted to start with reviewing what we did last time. So remember that one of the equations that we had was this: r is 1 plus sine theta. So what we said was that in this case it suffices to sketch the graph of this equation for theta between 0 and 2 pi, and the reason being that this function sine theta is a periodic function with period 2 pi. So let's say we want to determine then where is r increasing and decreasing, right? That's what we wanted to do. So because in this case, usually if you want to know where a function is increasing and decreasing, what do you have to do? You have to find the derivative, you have to find the critical points, and you have to divide the domain into subintervals, and then you determine where the derivative is positive and negative, and that tells you where the function is increasing and decreasing. However, in this case, since we know the function sine theta very well, we know where it's increasing and decreasing, so we can just directly determine where r is increasing and decreasing. So remember what we did, we made this picture where we said at theta equals to 0, r is 1, theta equals to pi over 2, r is 2, theta equals to pi, r is 1, theta equals to 3 pi over 2, r is 0, theta equals to 2 pi, r is 1 again, right? You guys remember that? How did I find those values? Well, what is r? r is 1 plus sine theta. So what is the value of r at pi? Well, the value of r at pi is 1 plus sine of pi, right? And that's 1 plus sine of pi is 0, so 1 plus 0 is 1. So that's how I'm getting r equals to 1. So now we have to determine whether r is increasing and decreasing in each of these intervals. So between 0 and pi over 2, the sine function decreases, right? Sorry, the sine function increases between 0 and pi over 2. So 1 plus sine theta will also be increasing. So I have it's increasing in that interval. Between pi over 2 and pi, the sine function is decreasing, so 1 plus sine theta will also be decreasing, and so we have that is decreasing up to pi, and then the remaining is similar. Between pi over 2, pi and 3 pi over 2, sine is decreasing from 0 to negative 1, so we have 1 plus sine theta is decreasing as well, and then it increases after that. So how did we draw the curve? Well, everybody is clear on this step? How did we draw the curve? Well, we said, well, let's just plot a couple of points. So the first point is when theta is 0. So when theta is 0, we get which point? When theta is 0, we get the point, let me use a green color maybe. When theta is 0, we get this point here, right? When theta is pi over 2, we get this point here, right? But it doesn't tell me exactly what's the pattern, so let's pick a couple of intermediate points. So when theta is pi over 6, right? When theta is pi over 6, what's the value of r? What was r? r is 1 plus sine theta. So if theta is pi over 6, it's 1 plus sine pi over 6. 1 plus sine pi over 6 is 1 plus a half. 1 plus a half is 3 half. So in that case, I am getting this point here. Where am I at? Yeah, so here's my 1, 2, 3. Oh, I see. So I picked unit to be right here, right? This was 1 here, so that's fine. What is the value of r at pi over 3? Well, pi over 3. So at pi over 3, the sign value is what? Root 3 over 2, and then you have to add 1 to it. So what you get is I guess it was what, 1.8 or something like that. So that's why I'm getting this point here. What's going to happen is that at 2 pi over 3, you'll see that you basically get a symmetric point from the point at pi over 3 from the y-axis. You're going to get this point here at 5 pi over 6, which will be symmetric from the point at pi over 6. What's that? Yes, that will be up one more. Thank you. Small eraser. Okay, so I would be getting right here, right? Okay, and then at pi, we're going to get this point. At 7 pi over 6, we're going to get this point. At 11 pi over 6, we're going to go into this point here. Okay, so we see what's happening now, right? Because between 0 and pi over 2, what's happening? Between 0 and pi over 2, r is increasing, right? So the curve will look like what? Well, I have a hard time writing on this, but right? And between pi over 2 and pi, r value is decreasing, right? So what you have is this, and between pi and 3 pi over 2, what's happening? It's decreasing like this, and then it increases like this. Everybody's okay? This curve is known as what? It's a cardioid. Okay, if you look at so this is the graph of what? This is the graph of 1 plus sine theta, right? R is 1 plus sine theta. If you take r is 1 plus cosine theta, what's going to happen? It'll be very similar, except that it's not going to be on the vertical axis like this. It will be on the horizontal axis. It will be a cardioid, yes. No, that's not the case. Remember, we looked at cosine 2 theta, so that's what I'm going to do next. R is cosine 2 theta, right? That's not a cardioid. That's going to be 4 loops, right? So if I want to sketch R is cosine 2 theta, right? Now, in this case, again, it suffices to draw the curve for theta between 0 and 2 pi. Again, because cosine is periodic with period 2 pi, right? So, again, if I want to find where a function is increasing and decreasing, usually we find the derivative, critical points, determine where the derivative is positive and negative. But again, since I feel like cosine, we think of cosine 2 theta by now should be your friend, right? You know what's the graph of cosine, so that tells you how to determine where this is increasing and decreasing. So because I have 2 theta, so I'm going to break up my interval from 0 to 2 pi into multiples of pi over 4. Before I did it at multiples of pi over 2. Now I'm going to do it for multiples of pi over 4. If I do that, I get these intervals, right? 0 to pi over 4, pi over 4 to pi over 2, pi over 2 to 3 pi over 4, and so on, right? And then I will find the value of r. I will find the value of r at each of these points, right? So what's the value of r at 0? It's cosine of 2 times 0, which is what? Cosine 0, which is 1. What's the value of r at pi over 4? At pi over 4, it's cosine of 2 times pi over 4, which is cosine of pi over 2, which is 0, right? Everybody sees how I obtain these r values. So at each of these angles, multiples of pi over 4, you evaluate cosine of 2 theta, right? These are values of theta, so 2 theta would be twice that, so you find the r value this way. Once you find the r values, then what do I have to determine? I have to determine whether r is increasing and decreasing in each of these intervals, right? So how do I determine whether r is increasing and decreasing in each of these intervals? Well, let's look at the between 0 and pi over 4. What is happening between 0 and pi over 4? If theta is between 0 and pi over 4, right? What is happening to 2 theta? As theta varies from 0 to pi over 4, 2 theta varies from where? 2 theta varies from 0 up to pi over 2. Now, as theta increases from 0 to pi over 4, 2 theta goes from 0 to pi over 2, and then cosine 2 theta, what happens to that? Cosine 2 theta is decreasing, right? That's the x-coordinate of that. So as you go from, as 2 theta goes from 0 to pi over 2, cosine 2 theta decreases from 1 to 0, right? So I know that it's decreasing there. Between pi over 4 and pi over 2, what's happening? Between pi over 4 and pi over 2. So now I have theta between pi over 4 and pi over 2, right? Then 2 theta would be between what? 2 theta would be between this, right? Oh, this would be just pi. 2 theta would be between pi and pi over 2, right? So in that interval, as 2 theta goes from pi over 2 to pi, right? Cosine theta is going from where? 0 to -1, right? I'm thinking about the unit circle, right? Cosine 2 theta, as 2 theta goes from pi over 2 to pi, the value of cosine 2 theta will go from 0 to -1, right? So we have still decreasing up to -1, that's why. Right? I keep doing that, and then I come up with this whole picture, right? Is that making sense? How to obtain this figure for where r is increasing and decreasing. Everybody says how to determine where r is increasing and decreasing. Okay, once I have decided where r is increasing and decreasing, then my next step would be to draw it. So what are we going to do? We are going to find the value of r at each of these points, right? So that's what I did. Okay, so what's the value of r at 0? Theta equals to 0. Well, that's this point here. I'm taking this to be this length here to be 1. Okay, r value was 1, right? At 0. Now, what's the value of r at pi over 4? At pi over 4, the value of r was 0, right? At pi over 4, the value of r was 0. Let's pick some intermediate points. At pi over 6, what's the value of r? Pi over 6. It'll be half. That's why I have half of 1 here. And then what's the value of, I picked another point. What's the value of cosine 2 theta when theta is pi over 12? Well, cosine pi over 12, then 2 theta would be, theta is pi over 12. 2 theta would be pi over 6. Cosine of that would be root 3 over 2. So this is exactly root 3 over 2 here. Okay? You can use your calculator to estimate what is root 3 over 2. You'll see that you get, I think you probably get something like 0.8. Okay, so now what I did is, so we got all the points up to what? Up to pi over 4, right? up to pi over 4, is it increasing or decreasing? R is decreasing from 1 to 0. So we see the pattern here. We see the pattern here that we see that we get something like this. Okay? Now, between pi over 4 and pi over 2, what is happening? At pi over 4, I have this point origin. At pi over 2, I get this point here. Remember, at pi over 2, the value is 1 again, right? At pi over 2, the pi over 2, the value is negative 1. At pi over 2, the value of r was negative 1. So I don't get this point. I'm sorry. At pi over 2, I'm actually getting this point here, right? It's negative 1. So let's pick some intermediate points between pi over 4 and pi over 2. If I pick pi over 3, right? If I pick intermediate point pi over 3, what's the value of r? What is 2 theta now? Theta is pi over 3, right? What is 2 theta? 2 pi over 3. Where is 2 pi over 3? R cosine of 2 pi over 3 is negative. So where am I getting this point? Right up here. That's the opposite of this point here. Everybody's okay with that? So when you have pi over 3, theta is pi over 3, so your polar axis is directing at pi over 3, but you're getting cosine of 2 theta, which is cosine of 2 pi over 3, right? And we know that is exactly half, negative half, right? So I'm getting this point here. Everybody sees that. That's negative half. And then if I pick theta to be 5 pi over 12, if I pick theta to be 5 pi over 12, I actually get this point. That's negative root 3 over 2. Is that making sense? So, and finally, we already saw that we got this point here. So what's happening here? So we are getting something like this here. Am I making sense? I keep doing that, right? But I'm not going to explain what else, how else you're getting those points. But you see the point. You add those points like this. So here's the other part. Oops. Here's the other part. It's hard to draw on the tablet. Not that I'm bad at drawing, right? Okay. My wife thinks I'm bad at drawing, but I don't think I'm bad at drawing. But she is bad at math for sure. Okay, so everybody gets how I got the graph? Everybody's okay? All right. So so let's now look at this question. Remember that let's say I want to find the slope of the tangent line at the point theta equals to pi over 6 to the curve r is 1 plus sine theta. So we are talking about this first curve here, right? The first curve at pi over 6. I want to know what's the slope of the tangent. So we did some calculations last time on this, right? So because what should I do? Well, first of all, I have to express the curve parametrically, right? So that is, I have to convert the coordinates to the rectangular coordinates. So what is x? X is r times cosine theta. Y is r times sine theta, right? Everybody is clear? Now, what is r times cosine theta? That's 1 plus sine theta times cosine theta, and this would be 1 plus sine theta times sine theta, right? Because what is r? R is 1 plus sine theta, right? That's how we are getting this. Now, so then what is dy dx? What is dy dx? What's the formula for dy dx? Remember the take-home quiz you did? I gave you a parametric equations and you found dy dx. Now instead of using t, we are using theta, right? This c is a parametric curve. We expressed it in terms of parametric equations where the parameter is theta. So we have to find dy with respect to what? Theta. We have to find dx with respect to theta, right? And we have to divide. So what is this quantity? What is dy d theta? I have to find the derivative of y with respect to theta, right? And by using the product rule, what do I get? Did we get this? Plus cosine theta times sine theta, right? And in the denominator, it will be 1 plus sine theta times derivative of cosine, that's negative sine theta, plus plus cosine theta times cosine theta, right? Everybody's okay? Alright, so now we need to know the value of dy dx when theta is what? Pi over 6, right? So what's happening? I plug in pi over 6, right? So what do I get? 1 plus sine pi over 6 is what? Half cosine pi over 6. So I get root 3 over 2 here, half here. What is that? 1 plus a half times negative half plus root 3 over 2, root 3 over 2, right? Everybody is okay with that. Now, what am I getting in the denominator? What's that? Everybody realizes that I'm getting 0 in the denominator? Okay, from your quiz, if I get dx dt to be 0, what happens? Note that the numerator is not 0. The denominator, notice, the denominator is exactly equal to 0. You see that? 1 plus a half, that's 3 half, multiplied with negative half, that's negative 3/4, right? And the other term is also 3/4, right? Positive 3/4. So it's 0. So if from your extra credit quiz, when you got dx dt to be 0, what did you have? Vertical tangent, right? So because I have this, the slope is undefined so the slope at theta equals to pi over 6 is undefined. But we know what that means in this case, right? We know that it means that at this point the tangent is a vertical tangent, okay? Last time I didn't finish my calculations. I didn't know whether I was going to get 0, and I made a wrong picture, right? I didn't make a vertical tangent last time. Remember that at the beginning? Because I didn't realize you were going to get 0. And when I completed the problem in the other class, I saw that I was getting 0, okay? So the picture will be, I'll have a vertical tangent at 0. So usually that's why when you sketch curves, people will suggest that you also find out exactly where you have vertical and horizontal tangents. If you find those out, then you will see where the tangents are vertical and horizontal. In any case, so that's what we get, okay? Now let's do the same problem for. Let's do the same problem. So let's say again find the slope of the tangent line. Slope of the tangent line at theta equals to pi over 6, but this time to the curve r is cosine 2 theta. Okay, so that is, if you look at the picture here, we are trying to find what's the slope at this point here, right? What's the slope at this point? Now, how do we do that? Well, once again, we have to express the curve parametrically, right? So what is x? X would be r times cosine theta, which is cosine 2 theta times cosine theta. Y is r sine theta, which is cosine 2 theta times sine theta. Because if you want to find the derivatives of these two functions, you have to apply the product rule, and I'm a little bit lazy about applying the product rule. So what I'm going to do is apply a trig identity and make sure that I don't have a product anymore. Now remember, quite a long time ago, when we talked about finding integrals of products of trig functions, at that time I gave you an identity for this type of functions, right? This type of products. What is basically, remember there is an identity for cosine A, cosine B, right? What is that? What's the identity for cosine A, cosine B? It's half of what? Cosine of A minus B, so you get 2 theta minus theta, that's theta, plus cosine of A plus B, that's 3 theta, right? And what is the formula for sine A, cosine B? For sine A, cosine B, again, this would be in terms of sine. This would be sine of 3 theta plus sine of, here I'm thinking of theta to be A and 2 theta to be B. So this would be sine of negative theta, okay? Sine of negative theta. But sine of negative theta is negative sine theta. So I'm just going to change that. So this would be negative sine theta. Okay? So review the identities for sine A, cosine B, and the identity for cosine A, cosine B. You'll get that. So now, what is dy d theta? Well, the dy d theta would be what? Half of, what's the derivative of sine 3 theta? Derivative of sine 3 theta is what? Cosine 3 theta minus cosine theta. And what is dx d theta? That would be half what? Negative sine theta and negative 3 sine 3 theta, right? And then dy dx would be the ratio of the two. So half cancels out. I get 3 cosine 3 theta minus cosine theta over negative sine theta negative 3 sine 3 theta. Everybody's okay with that? We're taking the ratio of the two, and now we want to know the slope. We want to know the slope at theta equals to pi over 6. So what do I get? I get 3 times cosine of 3 theta, right? So if theta is pi over 6, what do I get? What do I get? Cosine of 3 times pi over 6 is what? Pi over 2. Cosine of pi over 6. Here I get negative sine pi over 6. Negative 3 sine pi over 2. And what is that equal to? Cosine pi over 2 is what? Cosine pi over 2 is 0. Cosine pi over 6 is root 3 over 2, right? And in the denominator, I get negative half. Negative sine pi over 2 is 1, so I get negative 3 here, right? Everybody's okay? So what do I get? I get negative root 3 over 2 here, and here I get negative what? 7 over 2. So I get root 3 divided by 7 at the end, right? So that's the slope of the tangent line at pi over 6. Okay. Everybody is okay with how to find these things. Any questions? Any questions at all? Okay, so that's that. So let me go back to